All right, let's take what we've learned and apply it to a couple of smaller, simpler examples here with a banking example. And you're going to see this a lot in terms of use of exponential functions because they grow exponentially. In terms of we start with $350, okay, and then we can earn interest. So we can make money on the money just being in the bank. Now, if we do that for 1 year, like we did in lesson 24, it's pretty simple. But if we do it for more than 1 year, then we've got to bring in exponents, okay? So we start how we did before with the initial value, and then we look to add 3.5% to 100% because we want to show this as an increase because our money is going to grow every single year. Now, it grows more and more and more because that 3.5% gets applied to a number bigger than 350 each and every single time. Now, how do we show this for 10 years? The only spot that we have left is the exponent. So that's going to show us multiplying by that number 10 times. But before I do that, you know that we have to change this to a decimal. So move that decimal point 2 times to the left, raise it up to the 10th power. Now it's all about the calculator. Okay, so let's get the calculator going, and you'd want to type in exactly what you see. So whatever you have in front of you is what the calculator can handle. So if it starts at $350 and you want to multiply it, so use parentheses by 1.035, close your parenthesis, use the up arrow to make an exponent that is bigger than 2 or 3 or whatever it is, and you want to use the number 10 to represent 10 years. Now, go ahead and press enter, and there you have it. Works out to be about $493. So you have gained about $143 just by letting your money sit in the bank. And isn't that a cool thing about interest? You don't have to do anything other than just let it be there, and it will make money for you. All right. Next up, example number 4. This time it's kind of just laying it all out there. If a savings account has a function that is represented by S, probably savings, T for time, an initial value of 250, and growing because it's over 1 at that rate, which of the following is true? Well, that 250, that initial value is not going to change. You don't move that decimal, so get rid of the one that says $2.50 and the other one that says $2.50. Those are out. Now we're looking at 1 and 3. This one is a 45% increase. This one is a 4.5. Well, if you move that decimal twice, you're talking about 104.5%. Where we want to focus is on the back side of this, the number bigger than 100. It's 4.5% bigger than 100. 104.5%, right? So we want to go with choice number 3 because of this increase in interest. Finally, we'll finish up with a question in which maybe we'll see a decrease. Which of the following equations models an exponential? Remember, y equals a times b to the x power, so that it starts at 16 and decreases, there I said it, at 8%. Well, if it starts always at 100% but loses 8%, 92% will remain. So which equation looks like that? Well, this one's got a 92 in it, but that's a linear equation, even though it's got the variable above the 2 there. Don't go with that. It's got addition. We haven't seen any negatives inside parentheses, so let's get rid of that. 92%, well, it's certainly not 1.08, so we would have to go with choice number 1. Okay, so there you have it, finishing up the notes for lesson 25. Let me know if you have any questions, and we'll see you on the flip side.